Welcome to Pure One. This is chapter 4.5, where we look into translation of graphs. In the previous chapters of chapter 4, we look into how to sketch different graphs. You've learned how to sketch cubic graphs, quadratic graphs, reciprocal graphs, and what else? Yes, something about that. And then today, this lesson looking into more into how we can use those graphs to move around everywhere on the axes. So before we get into the actual transformation, have a look, have a look, have a look. No, you don't look at it. You do them. Do the starter question. Okay. Pause video. You should know how to do substitution. Okay. Pause video. When you're ready for the answer, you can press play. Here are the answers. Okay, here are the answers. Let me just check. Yep, here are the answers for the question. All right, 4, 9, 16. So I'll let you carry on, have a look. The main thing is about substitution for the algebra. The x plus 1 inside a bracket means you replace every x by x plus 1. But when the plus 1 is outside, means you do the f of x and then plus 1. So that's a big thing that you must know, right? Okay, next. Next, we're looking to transformation of graphs. So in here, you would see an y equals x squared graph. Okay, so you read y equals x squared graph. Now let's see if we do the plus 1, okay, inside the bracket. Let's see what happened then. Okay, maybe you can find, maybe you could tell me what kind of transformation is this. Now, if we do plus 1, we're here, the blue graph. We do plus 2, the green graph. When we do plus 4, we're here, always compared to the red graph. So what do we see? Now, what about if it's a minus 1 instead of plus 1? What happens if we have a minus in that bracket? It's here. Minus 2. Can you guess? Yep. And minus 5? Yeah. Okay. So what do we know? Now, if I just do the x plus 4 squared and x minus 5 squared, now you can see if it's a plus 1, plus 2, plus, if it's a positive inside the bracket, we move to the left. If it's a minus, we move to the right. Okay, so if the number is inside bracket, we move to left and right. So in here, f of x plus a represents a translation of f of x by vector minus a 0. Now, that's the proper way of saying it, but, we can use the simpler words. We don't like to play with words. Okay, simpler way to say is we move, okay, to the left by a, okay, or move to the right or right by a. So we do the opposite. So we move left and right, but you have to remember it's the other way around. If it's plus a, we move to the left. Okay, so positive a, left, negative a, right. Simple as. All right. What about f of x plus a? So if we have x squared plus 1, okay, so this is, you can see this different to the number 2. So if you look at equation 8 and equation number 2, you can see the plus 1 is out on the outside. That's f of x plus 1. So now compared to red graph, the green graph is here. X plus 2, the purple one, x plus 3, x squared plus 3. Now you can see moving up. Now you could guess x squared minus 1. Yep, move down. Minus 3, move down. Minus 5, move down by 5. So it's exactly by how much we put the number out behind the x squared. Plus 1, move up by 1. Plus 2, move up by 2. Minus 1, move down by 1. So in here, the proper way of writing is a translation of f of x by vector 0, a. Is 0, a. It's not minus a because we follow exactly the sign of a. It's a minus a on the f of x plus a because we do the opposite. So in here, okay, so we move up if a is positive. We move down if a is negative. Right? Simple as. All right. When a person is negative, of course they're down. Of course they're down. Anyway, joke aside. Let's have a look. Example here. Sketch g of x equals x times x minus 2. Before we start, what type of graph is this? It's a quadratic graph because if you try to expand the bracket, you get x squared. That's the biggest power. The degree is 2. So therefore, it's a quadratic graph. So in a quadratic graph, okay, let's try shape. Same thing, the 3 steps, U shape. When y equals 0, or when x equals 0, it doesn't matter which one goes first. So when x equals 0, you get y equals to 0 times 0 minus 2, which is 0. When y equals 0, you get 0 equals to x times x minus 2. So x equals 0, or x minus 2 equals 0. So x equals 2. So therefore, the graph looks like this. Here, crossing through 2 and 0, 0. When you get the y-intercept at 0, you're guaranteed one of the x value is 0, because you can't be crossing the y-axis at 0 without crossing x-axis at 0. 0, 0 is the origin. So x and y, that's the answer for part A. All right, part B. Sketch g of x plus 3. So g of x plus 3 now represent that means we're moving to the left by 3, okay? Because the plus 3 is inside the bracket. Inside bracket means left or right. X is rebellious. X does things oppositely. So if it is inside a bracket, it affects the X. So it affects the X, we move to left by 3. When I say affect by X, because when you move left and right, we are changing the X coordinates. What about the Y coordinates? No, it doesn't. It doesn't change it, because if you have a look in this one again, okay, so if we have a look in this one again, let's say this one, you can see at this point, 0, 0, minus 1, 0, oops, minus 1, 0, minus 2, 0. So the X at the Y value doesn't change when we move left and right. Therefore, it affects the X. But when the A is outside, it affects the Y. So if this affects the X, we do the opposite. Plus 3 means we move to left by 3. So we take note of the key points in here. We got 1 point, 2 point. Okay. We should know this point, because this point will be using symmetry of quadratic graph. We know that point is not minus 1, 1, because symmetry just has to be, it has to be symmetrical through the roots. So we move to left by 3. Okay, that means the 0, 0 becomes minus 3. The 1 becomes 1 minus 3 is minus 2. The 2 minus 3 is minus 1. So the graph looks like this. Oh, what happened to my minus 2? Minus 2. All right, x and y. That's the answer. All right. Okay. Question C. Sketch g of x minus 5. G of x minus 5 means we're moving the graph, moving down by 5. We're moving the original. Remember, we're not moving the translated graph in part B. We're moving the graph in part A. So therefore, it affects the y coordinates. The 0, 0 in here becomes a minus 5. So therefore, the graph looks like this essentially. Yeah. Okay. Now about the roots. Are the roots still 2 and 0? No, because when you move down, this point here, where it was 2, 0, becomes somewhere here, which is 2 minus 5. And this 0, 0 becomes here 0 minus 5. So we still have our 3 points in here where this is 1. This minimum point is still 1 because we moved the graph down by 5. That means only affect the y coordinates. That makes sense. So this point where it's 1 something, it will remain as 1 something. But it's just it's just 5 below the something, the previous something. If you understand what something I'm talking about. Yeah, hopefully something in your brain does make something sense. Right, next one. So again, ultimately what we're trying to say in here is if it's f of x plus a, means we move to the left and right. So if the A is inside bracket, we're moving left or right. Depends if it's a positive or negative. We do the opposite. All right. Plus a means negative to left, negative a means move to right. If the plus a is outside bracket, means we're moving up or down. Positive, up, negative, down. Hopefully that's straightforward enough. Okay, practice question 1. Okay, you will have to sketch a graph of f of x equals 1 over x. So it's a reciprocal graph, and write down the equations of the asymptotes. All right, so pause the video, have a go at this practice question 1. If you need help on any of them, I'll give you the answer one by one. Okay, part A and then pause, part B, pause, part C, pause. So have a go at part A first, and when you're ready for the answer, you can press play. Well, here's the answer for question A. Hopefully you do remember how to sketch a reciprocal graph. One thing to note is these lines should never touch the axes because there are 2 asymptotes in here, one on the y-axis, one on the x-axis. Asymptotes means the graph will never touch them. It's like an invisible wall where we can never pass, right? So the y-axis, the equation is x equals 0. The x-axis is y equals 0. Okay, so have a go. Part B, think about what transformation is this, okay, and try to sketch a graph, right? So when you're ready for the answer, you can press play. So here's the answer. F of x minus 4 means we move to the right. We're moving right by 4. So when we move to right by 4, so I should have used dotted line for the asymptote in part A. So hopefully you can see now these are the asymptotes. We don't normally draw the asymptotes when they're on the axes because the axes are usually bolded. So if you bold, but if you try to draw a dotted line, then you probably won't see it. But as soon as we move it, then we can see the dotted line. We have to show the dotted line as well. So you can see in here, the x-axis still here, the dotted line still there. But for the asymptote on the y-axis, we move to right by 4. We move the whole thing right by 4. So the asymptotes are, the equation is, the straight line here is x equals 4, and the horizontal one is still y equals 0. Okay, now, knowing this, have a go part C. Pause the video. When you're ready, press play. Here are the answers for part C. +6 means we're moving up by 6. So if you have a highlighter, highlight +6 means we move up by 6. -4 inside bracket means we move right by 4. So we move up, the horizontal asymptotes get moved up as well by 6. Therefore, the original asymptote where y equals 0 now get moved up into into y equals 6. So in here, so the vertical asymptote x equals 0, horizontal asymptote y equals 6. So these are the equations that you have to write because the question asks for it. Okay, so one more. Okay, example, transform graphs. So for this one, part A, sketch y equals x squared plus 3. Now, hopefully you do know, okay, the parent function. So the parent function means the original, okay? So if you think about, I don't want to call out ladies, but imagine ladies without makeup. That's original. That's a parent function. That's original. OG, that's original. Okay. Once you put +3, once you put a transformation, okay, then they are the makeups. Hopefully I don't get in trouble for saying this. So the parent function is f of x equals x squared. That's the original. The original looks like this, right? So the x squared. Hopefully I don't get in trouble into this. Don't sue me, please. Don't. You know, it's just a joke. An analogy is just so you can understand. Now, when we do x squared plus 3, think about the plus 3. How does it affect the f of x? When we have a +3 on the outside, x squared plus 3 means we're adding 3 on the outside of f of x, means we +3 on outside. What it means is this one means we're moving up by 3. So by noticing this is a transformed graph to the original, it can help us to sketch a graph. We don't have to do the 3 steps. We do shape, x equals 0, y equals 0. We can just do it very quickly because now the graph we know now looks like this. We move the graph up by 3. And that's the answer. Right, that's the answer for question A. Right, B, what about B? Now, have a look B. Guess how many transformations are there? Okay, 2 questions actually. That's the second question. The first question is, guess what is the parent function? So what is the parent function? And second question is, how many transformations are there? Is there? Okay, the parent function is f of x. Now, there are 2 answers to be this one, okay, to this one. The first one is 1 over x, or the second one is 2 over x. Now, the 2 does not do anything for this one, for reciprocal graph. I'll tell you why, because reciprocal graph, the 2 on the top means we're doubling. You will see next lesson what kind of transformation we did with doubling. But with a reciprocal graph, it doesn't really matter how we, it doesn't affect how we drew it. So therefore, the parent function of this one, I'll let it to be 2 over x. Then, what about f of x? Now, this time, the +1 is inside the x. Now, why is that inside the x for the +1? Because if it's outside, it'll be 2 over x plus 1. So this f of x plus 1. But the question is asked for f of x plus 1 inside because the +1, you substitute x plus 1 before you get divided by 2. Okay, so notice the difference. Okay, so this is the wrong one. Okay, so f of x plus 1 means we are moving which way, left or right? Left by 1. Okay, so +1 means we move to the left by 1, do the opposite way around. So where the original cross at 0, 0, we move to the left by 1, means we're now crossing at -1, 0. And that's the answer. Okay, now what you probably some of you might have a question for me. Sir, what about the y-intercepts and y-intercepts? Well, thing is, because when we move to the left, we don't have to, because there is no y-intercept in the beginning. When we move this point, which was this point, maybe it's that point there, these points are not important unless they give you, usually in the exam, if they want you to draw, to find the y coordinates, they will tell you, they will ask you in the exam. Okay, so it's a separate question saying, can you also label clearly your y-intercepts and your roots? So otherwise, you should be fine. So have a go, practice question 4, write down the parent function, and then work out the transform graph. Okay, pause video, have a go at the question. When you're ready for the answer, you can press play. Wait, actually, I just realized I made a mistake in part B because the parent function is not a quadratic. Sorry, it's not a quadratic. So I was wrong, totally wrong. So let's have a go again. My bad, my bad, my bad. Let's have a go again. Sorry. So 2 over x. Sorry, the parent function original graph is like this. Sorry, my bad, my bad. That's original. Okay, that's original. OG f of x. F of x plus 1 means we move to the left by 1. Sorry, my bad. So that means we move to the left by 1. Means we have an asymptote here at -1. And the graph looks like that. Okay. Sorry, this is the final answer. F of x plus 1. This is the final answer. Okay. Again, here's the answer for practice question 2. Okay, so here are the answers. All right. If you got it right, well done. There, I think that's the end of lesson for you. All right. If you don't, we'll go through. Okay. Question A, the parent function. So what's the parent function for question A? The parent function is negative, or f of x equal negative x squared, because negative x squared means like this. Hopefully you do remember this. So when you have -4 on the outside, oh, I made a mistake again. Right, okay, I made a mistake again for question A. Too many mistakes in here. Apology for that. So f of x squared -4, x squared -4 means we move down by 4. Just checking, see who is listening. You probably listening to this video, probably enraged, having your fist pumped up, ready to punch the monitor, saying, this is rubbish video. How did the teacher get all of them wrong? And here's a -4. But I ever make a mistake, and so do I. Here's the answer. Yeah. All right. This is the real answer. I was just checking, see who is understanding. Right. So then you have f of x -4 means you're moving down by 4. So you're moving down by 4. So from 0, 0 becomes 0 -4. Of course, that was what I meant from the very beginning. Part B. The parent function was f of x equal 3 over x, which the graph looks like this, just a normal reciprocal graph. When you have f of x, this time +2 equals 3 over x plus 2 means we move up by 2. Okay, therefore, the asymptote where the x-axis become y equals 2. All right, and the vertical asymptote remains unchanged on the y-axis, but we don't normally draw it out because it's on the axis. Okay, and that's the end of chapter 4.6. I mean 4.5, I still make a mistake at the end of the video.